All right, we are Team Hermes. Our app is an emergency services router. The purpose of this app is to connect a user-specified accident location with the appropriate emergency services. So that could be EMS or emergency medical services, police, or fire. And this builds on the 414 term project called Optimal Route Finding from 2017. The guts of this tool is the network analyst package in ArcGIS. The way it works is you give it some kind of data, in this case roads, and it creates what it calls a network, and it finds all the intersections of these line segments on a road, and it numbers each of those intersections, and it creates this big long table of which intersections connect to which ones by which roads. And it determines a travel time by using the attributes that were built into this roads data set that we got from AGRC. We divide length by speed to get the time it would take to travel that leg of the network. And then you feed it locations, this case being the emergency services and the location of wherever the accident is, and also blockages that could occur on the roads, like if a road was shut down because of a fire or a crash or any number of reasons. Yeah, like the Rexley run or all the races that go on. And then there's just a tool called Solve, and this is an example of what it looks like when you've run the tool. This is the closest emergency service. This is the dot that you chose, and this is the obstructions that you draw just in whatever pattern to reflect the roads that you can't cross. This is what it looks like as a workflow. If you start up here in the top left corner, you build this network of roads, and the tool is called Closest Facility. So you create this closest facility later, and then you just start feeding it all the locations, like where the fire is, where the fire stations are, where the blockages are. In this case, this is from the 414 tool, and they were concerned about parades, so their blockage is called a parade. And then you run the Solve tool, and it gives you a piece of the network that connects where you clicked to the closest service. This is what it looks like in the model that we built for our app. Same thing, except we had to create or make all of the different layers a parameter so that it worked with the service, and we had to add on a select data tool to the ends to export the result as a layer that could be returned in the service. Just summarize that. This is what it looks like on the Arc server. There's a total of 6 different functions, or 6 different services. The first 3 are different data services for the medical, fire, and police station locations, and the other 3 are routers, and you have to have 3 different ones so that you can add the appropriate data sets to the workflows.
Okay, and I'll talk a little bit. So what we wanted to do is to allow the users to store these layers and like retrieve them later if they found anything interesting in their analysis. So we used PostGRE SQL. It's the database that comes with with Tethys. And then there's Tethys persistent store settings. You can see in that code, you just need to add that code snippet into your app.py file, specify your database name, and just a function to initialize your database, and it will set that all up for you. We stored the layers as JSON data, which we retrieved from the analysis in the database. And then to manage the database, you can see it was a tool called pgadmin4. It's in that image right there, which allowed us to view the tables and the rows in the database so we could see how everything was working.
Alrighty, so I'm going to give you a little demonstration of how our app works once it loads here. So the extent of our app is Utah County. So, and on the map, it's going to show the EMS locations in the little cross, fire stations in the triangle, and the police stations with a P. If you click this button right here, it will allow me to place a marker for where the incident's going to take place, where I'm at, where I want the emergency services to respond to. This polyline button here, I can create some blockages. So let's say I'll block off that. And then I can select which emergency services I want to respond to me. So in this case, we'll just go ahead and click all of them. And then you click Analyze, and it will route those services to you. So we had one little bug, and we're not sure quite why it happened, but for the first one that we select, it won't take the blockage into account, but then everyone after that it will. So you notice on this one, the medical router is cutting through the blockage, and the other two are going around it. We had the exact same code for each one, and we're not sure quite why that happened, but for the first one that we do every time, we weren't able to get the blockage to work out. It'll show you your lat and long of your point. You can also click Save Results, and then like Wade was talking about on our database, if you click the Save Results tab, then you can toggle all your saved layers that you have. We'll wait for this to load, and we'll turn on this layer. So that's the blockage, the location, and the routing that you had that we saved to there. So you can save as many as you want, and that's our app. Do we have anything more on the?
Wade's got a conclusion.
Okay, all righty. Go back to Wade.
Okay. Okay, yeah, so just to conclude what we did, so some of the improvements we made is that we actually allowed the user to draw obstructions rather than having to create a shapefile. And they were able to draw the obstructions however they liked. And you could route to any of 3 emergency services with police, EMS, and fire instead of solely fire. We also implemented a database so we could store the old results for them to retrieve those results. So further work that we feel could be done, if anyone wanted, would be to allow the users to draw multiple non-connected line segments. As of right now, if you tried to draw 2 line segments, it would clear the other one. We could also allow them to change the styling of every layer to make it however they want. We could improve the database in being able to store more results. I think it's actually capped at like 10 right now, but we could make it at anything. No, you're fine. There's also an error in the time steps, and one thing that we would also thought would be cool would be to send driving directions somehow. So those are some improvements. Thank you.